Ever pondered about the significance of logistic regression in the realm of machine learning? Well, it's time to unravel this mystery. Picture a world where everything is either black or white, yes or no, true or false. In the realm of machine learning, logistic regression thrives in this world. It's a statistical model that uses a logistic function to model a binary-dependent variable. In other words, it deals with situations where the outcome can only be one of two things. Think of it as a yes-no question. Will it rain today? Will the stock market go up? Will this email be spam? These are the questions logistic regression can help answer. Now let's dive into the mechanics of it. Step 1 is understanding the logistic function, also known as the sigmoid function. It's an S-shaped curve that maps any real-valued number into a value between 0 and 1. This function is the heart of logistic regression, transforming its inputs into probabilities. Step 2 is all about estimating the probabilities. Here's where logistic regression uses the concept of odds ratios. The odds for an event is the probability of the event happening divided by the probability of the event not happening. In logistic regression, the natural logarithm of this odds ratio becomes the dependent variable. Step 3 revolves around the concept of maximum likelihood estimation. This method estimates the parameters of the logistic regression function. It finds the values of the parameters that maximize the likelihood of making the observed data most probable. The final step, step 4, is about making predictions. Once the logistic regression model is trained, it can predict the probability of occurrence of an event. If the probability is greater than a threshold, usually 0.5, the model predicts the outcome as yes or true. If not, it predicts no or false. To summarize, logistic regression is a powerful tool in machine learning used for binary classification problems. It starts with a logistic function that maps inputs into probabilities. It then uses odds ratios to estimate these probabilities. The maximum likelihood estimation technique estimates the parameters of the logistic function. Finally, the model makes predictions based on these probabilities. So, next time you're faced with a yes, no question, remember there's a good chance that logistic regression could help you find the answer. It's a testament to the power of machine learning, turning complex data into simple yes or no answers. Remember, in the world of machine learning, logistic regression is your trusty guide to binary outcomes. It doesn't get black and white clearer than that.